Hello, so here's lesson 2. So we're still going to stick with the integration by parts, but this is where we need to do it more than once in a question. Okay, so go back to your notes jotters for me. Just going to take the heading as integration by parts. Hyphen repeated applications, because we're going to do it more than once. Okay, just going to write a quick wee sentence before we start the example. So sometimes we may have to use integration by parts more than once in a question. Okay, so sometimes it's not as obvious if we need to do it once or if we need to do it twice and so on. But you should be able to notice that we need to do integration by parts and then realise it doesn't actually work out as nice as we thought it would. Okay, and that will all make sense when we do this example together. So example number 1. Oops. Okay, so it's the integral, there's no limits this time, of x squared cos x dx. Okay, so this is your question. Alright, so the only thing that you should realise right now is we're integrating and I've got two functions of x that's been multiplied together. So straight away you should be thinking, right, it's the integration by parts. Okay, and you would be correct in saying that. So let's set up integration by parts. So the one that becomes simpler when you differentiate is going to be your x squared, because obviously any trig function stays as a trig function when you differentiate it. So that will always be v dash. So at the side here I'm just going to write u equals x squared and v dash is cos x. Okay, so nothing new here at all. So if we differentiate u, that's going to give us u dash. The derivative of x squared is just 2x. And likewise, if we integrate v dash, that will give us v. And if you integrate cos, that just goes to sine x. Okay, so as always with every single question, I'd recommend that you write the formula down. So it's uv minus the integral of u dash v. Okay, so nothing new here. So let's set up our integration by parts. So I've got uv, so it's x squared times sine x. Just write it as x squared sine x. Take away the integral of u dash v. So u dash is 2x, v is going to be sine x dx. Here we go, okay? So now what would normally happen is you would keep this first bit the same and then you would just integrate this part and then that's you finished, okay? But see, if you look at this integral, think to yourself, right, how on earth am I going to integrate 2x sine x? Because I've still got two functions of x being multiplied together. So the only way that I am going to integrate, I'm just trying to get the highlights out. So the only way that I'm going to integrate this part is because I need to do integration by parts again in this. So it's twice in the one question. Now things are going to get messy here. Okay, so if I were you, if you've got a different coloured pen, I would change the colour of that just to keep the two integration by parts completely separate. Okay, so this first part is going to stay the same. Okay, so x squared sine x take away. So it's just the bit in the yellow box that I need to do integration by parts on again. So I am going to change my colour to purple. So pretend that this part doesn't even exist. Okay, so see, for example, I'll get rid of this. Oh, that didn't really work. Oops, never mind. Just forget that this part even exists. We're focusing on that yellow box here. So if I just gave you that question and says solve that, you would do integration by parts again. So change the colour of pen, because it helps. You need to set up the side here, u and then v dash. So obviously u would be 2x, because that becomes simpler, and v dash would be sin x. Okay, so you know the drill by now. So if you integrate u, you get u dash, which gives you 2. And if you integrate v dash, it gives you v. The integral of sin x gives you negative cos x. Okay, so I need to do the integration by parts for that part there. So I'm just going to make the formula underneath here. So uv minus the integral of u dash v. Okay, so let's do that here. So uv is 2x and then negative cos x. So I'm just going to open up big square brackets here to keep this part completely separate from what I've got before here. So uv is 2x times negative cos x, so it's negative 2x cos x. I've just brought that negative sign to the front here. Okay. Take away the integral of u dash v. So u dash is 2 and then v is negative cos x. So that's going to give you negative 2 cos x. But I've already got a negative sign here, so 2 negatives make a positive. So that's just going to give you 2 cos x dx. Just like that. Alright. So it's a little bit messy. This is why I recommend 2 different colours of pen, because otherwise it will get very messy, especially with all your negative signs here. Okay, so I'm going to go back to my red pen. I'm keeping this part at the start just the exact same. Then I'm going to change my colour to purple. Right, let's simplify this big square brackets here in purple, and then I can think about multiplying out the brackets here. So keep the first part the same, so negative 2x cos x, right? Then if you integrate 2 cos x, cos just goes to sine when you integrate, so it's just plus 2 sin x plus c. Okay, so that's a yellow box integration by parts. It gives you this bit in purple, in the purple box here. Okay, so we're not finished yet. All we need to do to finish up is just to multiply out the brackets, and that'll be us done. Okay, so x squared sin x, I've got a minus minus, that just makes a plus, 2x cos x, then you get a minus sign times your plus 2x, or sorry, 2 sin x, gives you minus 2 sin x, then the minus sign times your plus c. You could keep it as minus c, or you could keep it as plus c. C is just a constant, so it doesn't actually matter what coefficient's in front of it. The c would adapt to that. Then just the one double check, can you simplify anything in here? There's no obvious highest common factors that I can take out, so then we are finished that. Okay, so I'll scroll back up. Feel free to pause the video at any point just so you can look back at everything, and I would recommend using 2 different colours of pen just for each of the integration by parts, because it will get very messy, trust me. Okay, once you're finished with that and you're happy with that, if you can go back to your textbook, and it's going to be page 58, questions 36 to 41. Okay, remember there are answers at the back of the book if you need to double check them. Okay.